We are doing the law of conservation of momentum, and Anthony will explain the formula.
Yes, the law basically states that the total initial momentum equals the total final momentum.
And now we're going to do some examples.
That, my friend, was an example of an inelastic collision. Back to Winder.
Okay, so the total momentum before the collision is 420 newtons. So therefore, the momentum after must equal 420 newtons. And to find the velocity, since momentum equals mass times velocity, you divide 420 divided by 82, and you get 5.12 meters per second. Okay, that was another example of an inelastic collision. Now here's Anthony.
Okay, so to get the total momentum, you have to take Luke's momentum, which is 400 newtons, minus the momentum of the ball, which is 20 newtons, because the ball is traveling in the opposite direction. And once you get that, you divide it by the final mass, which is 82 kilograms, and you get 4.63 meters per second, thus proving that the law of conservation of momentum has been in use.
That was another example of an inelastic collision.
The momentum of the football is 0 newtons, and the momentum of the man on the skateboard is 400 newtons. So, after, the momentum will also be 400 newtons. Then you can find the velocity by dividing by the mass, and you get 4.9 meters per second for the velocity. This is an example of how momentum is conserved before and after, thus proving the law of conservation of momentum. We showed you examples of inelastic collisions, and now we'll show you examples of some elastic collisions. As we saw in an elastic collision, the objects split apart instead of staying together after the collision.
The momentum is the same before and after due to the law of conservation of momentum.